Hello. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in the Databricks playlist, and in this particular video we are going to talk about Unity Catalog. We have already talked about Unity Catalog a bit in the previous videos also, and we are just aware about that Unity Catalog is a centralized system using which we can do the data governance in our Databricks workspace. But how exactly this governance works, how depending on the kind of table and the kind of workspace that we have, Unity Catalog differs, how we can create our own Unity Catalog, and what are the limitations of Unity Catalog. All these things we are going to see in this particular video. So in this particular playlist we have covered Spark already from very scratch till the advanced concepts of Spark. So if you are someone who is trying to learn Spark from the very basics, or someone who just wants to brush up the advanced concepts, this particular playlist can be very helpful for you. So let's get started with this particular video and let's get straight into our system. So we are already aware about the fact that what exactly Unity Catalog is, right? And like how it introduces the data governance on the data and even the AI models that we have in our Databricks workspace. So in this video, what we'll be doing is that we will be reading the documentation, because obviously this is the most in-depth, uh, I would say, resource that we have, right? Anywhere in the Unity for the Unity Catalog thing, right? Because no one other than the developers of those particular thing can explain you that what exactly that thing is, correct? So we'll be going through the documentation and we will be understanding the Unity Catalog part in detail. So first of all, let's understand what is Unity Catalog. Okay, so this article introduces Unity Catalog, a unified governance solution for data and AI assets on Databricks. It explains key concepts and gives an overview of how to use Unity Catalog to govern data. Okay, so Unity Catalog is also available as an open source implementation. You can see the announcement and public GitHub repo. Okay, so if you want to see the source code and everything of Unity Catalog, you can just click on this link, right? And this is the README file. If I go here, right, so you will be able to see each and everything, each and every line of code of Unity Catalog that is there, right? So mostly I can see the markdown files only. I guess in clients maybe I can find some kind of SDK. Yeah, in the clients you will be able to see each and everything. Okay, all the code and every stuff right here at your disposal. Okay, so if you want to go ahead and understand what exactly, like how exactly Unity Catalog works under the hood, so you can come here, but obviously it's not mandatory. I won't suggest you to invest that much of time that you are understanding the code and all the stuffs, but if in case you want to, so you can. Okay, here you can see this diagram which explains everything, right? That any format of data, right, it can be handled by Unity Catalog. So Unity Catalog is basically a kind of layer, right, in between your tables, objects and machine learning models, and between your maybe the cloud platform, any AI or data platform that you are using, or any kind of compute engine if you are having, right? So here you can manage views, external tables, managed tables, right? Any kind of data format, iceberg, delta, hoodie, right? Parquet, JSON, CSV, any file format you can work on. You can have objects, you can have any volumes, right? Object storages in S3 and everything, where you can have images, audios, PDF files. For talking about the AI and machine learning part of it, so you can have your functions, you can have your machine learning models, you can have vector databases, right? And on top of it you can implement the Unity Catalog. What it will do is it will enable the delta sharing using iceberg REST API catalog and all these things, Unity REST APIs. It will unify the governance on top of your table, objects and machine learning models, and then you can connect to this Unity catalog further with your any of your cloud platform, any of the data or AI/ML platform if you want to use, and even the compute engine, right? Similar to, if you can see, Apache Spark is also there in the list. If you want to use Trino or any other processing engine, you are free to do it. Okay, so just a very overview, like a basic overview of Unity catalog, what Unity catalog is, right? How you can do the things, what all prerequisites are there, right? How you can run the Unity catalog server and everything. So if you like, if you want to self manage basically the Unity catalog part, so you can also do it, but here everything is managed by Databricks only. Okay, so let's get started with the documentation now. So overview of Unity catalog. Unity catalog is a centralized data catalog that provides access control, auditing, lineage, quality monitoring, and data discovery capabilities across Databricks workspaces, right? So I don't think anything needs to be explained too much here. So it is a centralized data catalog. If you come here also, you can see that there is one single unified governance, uh, system, right? On top of your data, it can be table, volume, or anything, which provides access control, right? So to whom and how much access do I want to give, right? Using the ACL, that was access control list, was created, right? Whatever kind of access we want to provide to whoever users, it was provided by ACL, right? So access control. So the metadata of ACL is handled by none other than Unity catalog. Then the auditing, right? What all things, right? Maybe the audit logs and everything, it's handled by Unity catalog itself and the metadata of it. Then the lineage, what was the data lineage, like what was the original format of the data, how it got transformed during multiple transformation processes, and then ultimately landed up to the current state in whatever state it is in that particular period of time. Then the quality monitoring. So what is the quality of the data currently in my, maybe the lake house, or maybe in any kind of table, that can also be monitored using our Unity catalog. But this quality monitoring we won't be able to do in the free tier edition. It is only available in the paid version of Databricks. And data discovery capabilities is also enabled across the Databricks workspace. Okay. Then if I talk about the key features of Unity catalog, so the very first feature is define once, secure everywhere. Okay. So Unity catalog offers a single place to administer data access policies that apply across all the workspace in a region. Okay. So you need to keep in mind one or two things, right? Firstly, that if you define your Unity catalog, right? Let me change the color once. Okay, so if you define your Unity catalog, it is only applicable in one single region. So what exactly this region is? So if I come here in my Databricks, and if I click on this drop down of my compute, right? Okay, it should show. Right, let me just click on the serverless ones. I guess I will have to refresh it. Okay, so now if I click on the serverless compute, why it's not visible? Let's click on this more. Serverless budget policy. No, I want a general compute. Okay, and if I click on this drop down, showing me the serverless, so I can start and attach this server once. Code assistant inactive. Activate once for this session. Okay, you don't want any kind of code assistance. Let me run this cell. In that case, it will automatically attach. Let me run this cell. Not very sure that from past 2 or 3 days, Databricks is not responding in a good way. Right? It has too much of lag and all those stuffs. Okay, click on this drop down. If I display my data frame, okay, now the serverless has been attached and I'll be able to see my region now. Not very sure. Okay, even now it's not showing. If I go to home and if I click on this workspace, I guess workspace. Okay, fine. Okay, it was not in server. Okay, if I go to home and if I click on this workspace, so you can see that my workspace is deployed on this region, that is US East 2. Okay, so if I'm correct, so this region is the North Virginia region. Okay, so there are different regions, right? There are different data centers at different parts of the world, right? And they are just given some kind of code for their identity purpose, I would say, right? So like Databricks also has its region in Mumbai, that is called as AP South 1. Okay, so AP is Asia Pacific South, and one of the data center is there. So Mumbai region will be AP South 1. So if you have deployed on multiple regions, so you will have to create your data like data access policies for all those individual regions. You cannot use, like you can use, but it's recommended that you create the data access policy across all the regions wherever you have deployed your workspace. Okay, then talking about the standards and compliant security model. So Unity Catalog security model is based on standard ANSI SQL and follows administrator to grant permission in their existing data lake using familiar syntax. So this ANSI SQL is basically a kind of organization which gives us basically the admin access kind of queries inside the SQL. So ANSI is basically an organization which does a kind of data governance and all these audit checks for the SQL aspect of it. Okay, so like using the ANSI SQL queries like grant, revoke, and all these things, we can grant and revoke the permissions, right, in our Unity catalog. Okay, then we have the built-in auditing and lineage. So Unity Catalog automatically captures user level audit logs that record access to your data. Right? Unity Catalog also captures lineage data that tracks how data assets are created and used across all languages. Okay. So the very first thing that it will do is it will capture all the logs and the access of the data. Right. So if I go to my Databricks and if I go to my query histories, right? So here you will be able to see all the sources, right? If I just make it a bit more, wide. Okay, so you will be able to see what all queries are getting executed, right? When it started, when it ended, how much was the execution time, what was its duration, what was the source, means from where that particular thing ran, right? Source type, so was it a notebook, was it a BI tool, was it a job dashboard, and other things. What was the compute that was attached to it, who was the user, and who ran it, right? So all these logs and all these things are getting logged here, as well as Unity Catalog also captures the lineage data that tracks how data sets are created and used across all languages. Okay, so if I talk about this particular part, so if I go to catalog, right, so not very sure if we will have that lineage graph or not. If I go to default, right, tables, and if I go into, let's suppose, life table, so here you will be able to see something called as lineage, right? So here you are seeing that what is the direction, what all spaces are these, like this particular data is getting attached to, or where it is getting used, what is the direction. So direction, we have something called as upstream direction and downstream direction. So it means that from table we are ingesting that data into this particular workspace, right? If from this particular workspace data was getting ingested into the table, then it would have been an upstream direction. Okay, then what is the type, when was the last activity done, and all these things. If you want, you can also see the lineage graph right here. Okay, so same thing is getting shown in the form of a graph. That's it, nothing more than this, right? Here you are seeing it in a list format, here you are seeing it in a lineage graph format. Okay, so you can get all these details just because of the Unity Catalog server. Okay, or I would say the Unity Catalog service that is there on top of the Databricks part. Then the data discovery. Unity Catalog lets you tag, document data accesses, and provide a search interface to help data consumers find data. Okay, again, if I go to my table overview, so here I will be able to tag my data or add any kind of comment. Okay, so here if I am adding some kind of tag, and let's suppose if someone from some other team maybe, right, or some other person who is not able to, here also I can add tags to table also. I can add tags to column, to table, and all these stuffs. So if someone is only aware about, let's suppose, expectancy, okay, he is not aware about that. I have given the table name as life expectancy, he is only aware about expectancy. So if I can add a tag here as, let's say, life underscore expectancy, life, all these things, right? Let's say mortality rate and all those things. So with this particular tag, he will be able to search this particular table in my workspace. Okay, so this is how the tagging system and the data discovery will help. Then system tables. So Unity Catalog lets you easily access and query your account's operational data, including audit logs and billable uses and lineage. Okay, now talking about the meta store. So the meta store is the top level container for metadata in Unity Catalog. It registers metadata about data and AI assets and the permission that govern access to them. Okay, so meta store is the top level container in the Unity Catalog. So just like we have this workspace, right? On top of this workspace, there will be a container or a storage system, I would say, that will be nothing but our meta store. Okay, so this meta store is the topmost level of hierarchy or the container in Unity Catalog. It registers metadata about data and AI assets. Okay, so what all metadata will it register? It will register metadata about the data that we are having and the AI assets that we are having, and also the permissions that are given to access them. So what this line means? So this line means nothing but if I come into my catalog, and here I can see an organization that is named as system, right? And if I open this systems thing, you will be able to see few of the things that we have been talking from last 1 or 2 days, that is access of data, AI things, billing, compute, information schema, ML flow, right? Storage and all these things. So these are this is the place where my Unity catalog is storing all the metadata of all these services. If I talk about access, so you can see, right, audit log, you can see here, right, clean room events and all these things. Moving forward, you will see all these things in the documentation itself, right? Then if I talk about AI, right, so you can see the function that has been created here. You can see what all models are there. So this is not exactly the models, these are the metadata of the models. Okay, if I show here, so these are, you can see the description of the model here, right? You can see the details of the model, right? When it was created, by whom it was created, what is the model ID, where it is stored. So you can see it is stored in S3 bucket. Okay, in S3 systems table production, this, right, this bucket, then metastore, and inside this metastore, this is the model ID that it has. Then last updated, by whom it was updated, what all permissions are there to be what all permissions are there for this particular model to be used by whom, and all these things. So these are all the metadata of the models, right? This is not the original model, I would say, right? And all these things are given here. If I talk about let's say information schema, right, and inside it, if I go into, let's say, catalogs, okay, if I go into catalogs and if I go into this overview section, so you will be able to see what all metadata about catalog do we have inside our catalog. Okay, so we have catalog name, who is the catalog owner, if any comment is added to that particular catalog or not, when it was created, by whom it was created, when it was last altered, and by whom it was last altered, right? And again, if I go into this samples data and if I connect my compute to it, so it will take a few seconds, right? So here you can see the same overview or the same schema that we were having right here. The same details you are getting, the catalog name. So if I show you guys here, so we have three catalogs, that is systems, samples, and workspace. You can see them right here. Who is the owner of this catalog? So system user, for system and this samples catalog, system user is the owner, and for this workspace, we are the owner. Like, we means I am the owner currently of this particular catalog, right? If there is any kind of comment added, so I have not added any comment in the workspace catalog, so you can see null, and whatever comments are added here, you will be able to see them here. When it was created, right, by whom it was created, so these two catalogs were created by system, the workspace catalog was created by me, so you can see my email ID here, when it was last altered, and by whom it was last altered. You can see all the metadata of the catalog stored right here. Similarly, for other stuffs also, you will be able to see all the metadata in this particular systems catalog. Okay, so this is where metastore is basically storing the data into. Okay, so metastore is the topmost hierarchy. Metastore will manage all the catalogs that are present in like in one region. Okay, in one region there will be only one single metastore, and inside that metastore there will be a hierarchy that will be catalog. So let's read forward, we will be understanding everything. Okay, for a workspace to use Unity catalog, it must have a catalog metastore attached. Okay, you should have one metastore for each region in which you have workspaces. Unlike Hive metastore, the Unity catalog metastore is not a service boundary. It means it runs in a multi-tenant environment and represents a logical boundary of segregation of data by region for a given Databricks account. Okay, so multi-tenant environment means it need not install on every system or on every server. Okay, it need not be installed on every server. Okay, it can be installed on one single server, and it can be accessed everywhere in a particular region, and the data is divided by a logical boundary. Means if I come back again here, so all the access related things will be inside this access schema. Okay, or I can say schema is equivalent to database itself, right? So every access related system, or I would say access related metadata, will be present in this access schema. AI related metadata will be present in this AI schema. Billing related will be present in this billing schema. So here it makes sense, right? That it is a kind of logical separation between data, so that everything remains segregated. There is no kind of, I would say, a mixture of data, so that even the access is very easy. Let's suppose if I want to access my information schema, so I will just go systems.information schema, and whatever table I want to access, I can easily access it. If I know that I want to query some kind of, let's suppose, storage related service, so I can do systems.storage dot this predictive optimization operations history, right? So this is all the things I can do, right? Then unlike Hive Metastore, Unity Catalog Metastore is not a service boundary. It runs on a multi-tenant. Okay, we have already read about this. Then the Unity Catalog Object Model. So in Unity Catalog Metastore, the 3-level database object hierarchy consists of catalogs that contain schemas, which in turn contain data and AI objects like tables and models. This hierarchy is represented as 3-level namespace. That is my catalog dot schema dot table. When you reference tables, views, volumes, and models in a function. Okay. So as I told you, if I want to access any of the table, it will be a 3-level hierarchy namespace. First of all, we will have to use the catalog name, that is systems in this particular case. Then we have to use the schema name. Let's suppose any of the schema, that is storage, and then we can access the table by this. So we have catalog, then we have schema, and then we can have our table, we can have views, we can have volumes, we can have functions. So here you can see you have your tables. Here you will be able to see your functions, right? And you can see your functions. Most probably views will not be there, right? Everywhere you will be majorly able to see the tables, functions, and your models also, right? So let's first of all understand the level 1. Okay, so level 1 is catalogs. So catalogs are used to organize your data assets and are typically used as the top level in your data isolation scheme. So catalog is the topmost level in the data isolation scheme. Means this is where the data gets isolated, right? Separate from each other. Catalogs often mirror organizational units or software development lifecycle scope. Then non-data securable objects such as storage credentials and external locations are used to manage your data governance model in Unity Catalog. These also live directly under the Metastore. They are described in more detail in this particular link, right? Then there comes level 2, which are nothing but our schemas. So schemas, also known as databases, contains tables, views, volumes, AI models, and functions. All the stuff you can see right here, right? It can contain table, it can contain views, it can contain functions, AI models, and volumes, etc. Right? So schema organize data and AI assets into logical categories that are more granular than catalogs, right? So here it is more granular than catalog, right? So here you can only see the systems catalog. Inside systems catalog, there is again a further hierarchy, that is a logical separation. So it is on a more granular level than catalogs. Typically a schema represents a single use case, project, or a team sandbox. Cool. So it can, like, one schema can represent a single use case. Like here it is representing one of the use cases, like access is one of the use case, AI is one of the use case, billing is one of the use case. or even it can be on a project basis, or even a team sandbox. Means sandbox means like one of the team has created it for themselves. Then there is something called as level 3. So tables are a collection of data organized by row and columns, right? So we already know that table is the level where the original data gets stored, right? So it is a data, it is a collection of data organized into rows and columns. Table can be either managed with Unity Catalog managing the full life cycle of the table, or external, which Unity Catalog managing the access of the data from within Databricks but not managing the access of the table in cloud storage or other clients. Okay, so tables are of two types in Databricks. First one is the managed table, okay, and the other one is external table. So we are going to see like further in this particular documentation itself a, a very detailed information, or I would say a very detailed difference between both of them. So let's right now let's only understand that there are two types of table and even two types of volume. First one is the managed table and managed volume, and second one is external table and external volume, right? Then on level 3 we have also something called as views. So views are saved queries against one or more tables. We are very well aware about what views are, right? We have seen this particular thing in very detail in the previous videos. Then we have something called as volumes. So volumes represent logical volumes of data in cloud object storage. You can use volumes to store, organize and access files in any format, including structured, semi-structured and unstructured data. Typically they are used for non-tabular data. Okay, so we are already aware about this thing, that volumes are usually used for storing semi-structured and unstructured data. It can also store it can also store structured data, but mostly for storing the structured data we use tables, right? Typically we use non-tabular data, like we use volume to store non-tabular data. Volumes can either be managed with Unity Catalog managing the full life cycle and layout of the data in storage, or external, with Unity Catalog managing the access to the data within Databricks and not managing the access to the data in the cloud storage of other clients. Again, as I told you, that both table and volumes are of two types, managed and external. Then there are something called as functions. So functions are unit of saved logic that return a scalar value or a set of rows. Okay, a kind of UDF that we say, right? So they are something called as functions. Then we have models. So models are AI models packaged with ML flow and registered with Unity Catalog as functions. Okay, so ML flow registers the models, right, and it saves the model of different runs, right, and those models are packaged into the service. Okay, then there is something called as, like, okay, models are already done, that these are the packages, like packaged models which gets registered with ML flow and also gets registered in the Unity Catalog as functions. So these models get registered as functions inside Unity Catalog. Okay, then there is secureable objects that Unity Catalog uses to manage access and external data sources. Okay, so using what kind of secureable objects does Unity Catalog uses to manage the access of the external data sources? Okay, so in addition to the database objects and AI assets that are contained in schemas, Unity Catalog also uses the following secureable objects to manage access to cloud storage and other external data sources and services, right? So these are nothing but the external tables or the external volumes that we were talking about. Okay, so if I talk about the storage credentials, so there is something called as storage credentials, which encapsulates a long-term cloud credentials that provide access to cloud storage. Okay, so storage credential can be I would say correlated with the personal access token or the API keys. So it is a kind of credential that is provided by the cloud providers, which you can use to authenticate yourself that, okay, like I am the same user, and Databricks can get connected to this particular storage securely, and you can access the data in a secure fashion, right? Then there is something called as external locations, uh, which reference both a cloud storage path and storage credential required to access it. External locations can be used to create external tables or to assign a managed storage location for managed tables and volumes. Okay. So there is something called an external location, which refers to the cloud storage path. Okay. To the path where, like, to the cloud, right? Let's suppose if you are using S3 in the backend, so it will refer to that cloud storage path. It will refer to the S3's path. Okay. And it will require its own credential, that is S3's own credential, to access it. Okay. External locations can be used to create external tables. Okay. So creating external tables means, let's suppose if I want to host something on my S3 bucket, so that will be a kind of external table for my Databricks environment, and to assign managed storage location to managed tables and volumes. Okay. Then talking about connections. So connections, which represents credential that give read-only access to external database in a database system like SQL using Lakehouse Federation. Okay. So connection is basically a kind of, again, a credentials, right? A kind of authorization that will only give the read-only access. So you need to keep in mind that using connections, we can only read the data. We will not be able to do any kind of update, delete, like any kind of schema changes basically on the databases. Okay. And databases like SQL, we can, if it is hosted on some kind of other cloud platform, right? Let's suppose I am using RDS, right? So if I want to access my RDS into my Databricks, so I can use these connections, right? But in that particular case, I will only be able to do the read only thing, and that connection will be established using my Lakehouse Federation. Okay. And what is exactly Lakehouse Federation is, you can, if you want to read in detail, you can read in detail here. Then there is something called as service credentials, so which encapsulates long-term cloud credential to provide access to the external services. Okay. So service credential is again a kind of storage, right? Which will store the access of the external services, right? So it can be an external table, or it can be external volume, which we have in our Databricks environment. So the managing of that particular table or volume will be done by our catalog itself, but the data life cycle and the schema management and all those stuffs will be responsible, uh, like for managing all those things. So the cloud provider will be responsible for all those things. Okay. Then secure objects that Unity catalog uses to manage access to shared assets. Okay. So Unity catalog uses the following securable objects to manage data and AI asset sharing across metastore and organizational boundaries. So the very first thing are clean rooms. Okay. So we have seen clean rooms here in our access thing, right? If I come here, so you can see clean room events, right? So clean rooms, which represent a Databricks managed environment where multiple participants can collaborate on projects without sharing underlying data with each other. Okay. So clean rooms are a, an environment, basically a Databricks managed environment where multiple people can collaborate on one single project, but the data will not be shared with each other. Okay. They will only be able to see maybe the source code, the table and all these things, but the data will not be shared. Sorry, they may be able to see the source code, right? Maybe the notebooks of one another, the SQL queries of one another, right? They will be able to see, but the underlying data will be shared among them. So this is what clean rooms are. Then there is something called as shares, which are delta sharing objects that represent a read-only collection of data and AI assets that a data provider shares with one or more participants. Okay. So here, if I talk about shares, okay. So clean room we have already talked about. Then comes the share. So shares are the data sharing objects that represent a read-only collection of data and AI assets that a data provider shares with one or more recipients. Okay. So shares is a kind of object, right? So it is a read-only collection of data and assets. It means if I come here, right? If I show you guys even, and if I come into my models, right? So you can see there are multiple models that are already available here. Okay, let's say if I want to go ahead with, let's say, Databricks GPT-5, right? So you can see if I go into this permissions, no, not permissions, no, I have opened, I guess, something else. Yeah, if I go into models and if I go into, let's suppose, anyone else, details, permissions, share, I guess, no, not the share. I am getting this in catalog. Features, if I go into, not features, serving, yes, okay. I had to go come into servings, right? And now if I come into servings and if I come into, let's suppose, Databricks OSS, so here you will be able to see that there is some kind of endpoint API endpoint that is available for us, right? So this endpoint is only a read-only endpoint. We will only be able to hit uh, this particular model, and it will give us the response. Okay, we will not be able to modify anything. So it's a kind of read-only access for us. Then comes the recipients, which are the delta sharing objects that represent an identity receives shares from data providers. So recipients are the people who get the shared object, right? And providers are the people who share the object. Okay, so providers, which are object sharing objects that represent an entity that shares data with a recipient. Okay, so providers shares the object with the recipients and recipients get the object from the provider. Okay. Then comes admin roles. The following Databricks admin roles may have Unity catalog privileges by default. So the very first admin role is account admins. So he can create meta stores, link workspaces to meta stores, add users and assign privileges to meta stores. Okay. So account admins are the people who has the highest level of admin rights. Okay. He is the whole soul kind of owner of that particular account. So he can create meta stores, he can link workspaces to meta stores, he can add any users and assign privileges to the meta stores. Then comes the workspace admins. So workspace admins are the admins of one particular workspace. So we are already aware about this fact that the hierarchy in Databricks is something like this, that we have an account, right? And inside this account we have multiple workspaces, right? We can have multiple workspaces. So this can be, let's say, workspace 2, this can be, let's say, workspace 1. So we can have individual admin for these workspaces, right? So admin for workspace 1, so there can be a separate admin for workspace 2, and there will be a separate admin for this particular whole account. Okay, so this admin will be the will have the highest authority, and this admin will have the authority only in this particular workspace. This admin will only have the authority in this particular workspace only. Okay, then workspace admin can add users to a workspace and manage many workspaces specific objects like jobs and notebooks. Okay, depending on the workspace, workspace admins can also have many privileges on the meta store that is attached to the workspace, right? So it totally depends on the use case, what kind of privileges workspace admin can provide it to anyone, right? So what workspace admin can do, he can add users to the workspace, he can manage whatever objects are there in workspace, that is something like jobs, he can share jobs, he may share tables, volumes, notebooks, right? And he can also depending on the workspace admin can have many privileges on the meta store attached to the workspace. Okay, again, depending on the workspace, so depending on the accounts admins right given to the workspace admins, he may have some privileges on the meta store also. Okay, then comes the meta store admin. So this is an optional role which is required if you want to manage table and volume storage in the at the meta store level. It is also convenient if you want to manage data centrally across multiple workspace in a region. Okay, so meta store admins are an optional role. Okay, if you want, you can provide that particular role, but it's not mandatory from Databricks side. Okay, it is convenient if you manage the data centrally across multiple workspace in a region. Okay, then granting and revoking access to securable object. So how we can grant and revoke access to objects? So privileged users can grant and revoke access to secure objects at any level in the hierarchy, including meta store itself. Access to an object implicitly grants the same access to all the children of that object unless access is revoked. Okay, you can use typical ANSI SQL command to grant and revoke access to objects in in Unity catalog. For example, so let's say if you want to grant access of creating table on which schema on my catalog.schema. Let's suppose there is a finance team in my organization. Okay, and there is a finance schema that I have inside my catalog, right? So what I can do, I can run this particular query, right? I can run this particular SQL query that you can grant the create table access to my catalog.finance schema to which team? To finance team. And this finance team can be a group. This finance team can be a group, and these groups can, like this group can have multiple members attached to the group. So if I give this access to the whole group, so all the members present inside this group will be able to create a table inside my finance schema that I'll be having for my finance team. Okay, they will not be able to create the table in any other schema apart from this schema which I have provided to them. So only finance schema will be accessible to finance team. Maybe again I want to give some kind of access to the sales team. So what I can do my catalog, right, and I can create a sales schema, right, and I can provide whatever access I want to the sales team, right, to the sales team. So this is how I can micromanage my data sharing in the workspace. Okay, same thing can also be done using the UI. So if I go here and if I go to catalog, right, if I go to workspace, let's suppose the default, right, I can open any of the table. Let's suppose Hindi underscore table 1 I want to open. So here if I go into permissions, right, so here I can add some kind of permission. So I can click on privileges, right, no, not privileges, sorry, I have to go to policies, right, and I can attach a new policy. I can click on policy. Okay, not policy, I'm right now talking about privileges, right? So I have to come to permissions itself, right? Yes, I have to come into grant, right? Here I can add, let's say, all account users. If I want to add some specific user, I can enter his or her email ID. Then I can apply what all privileges do I want. Let's say if I want to give only manage privilege to all the users of this account for this particular table, only this Hindi underscore table 1 will have the manage privilege to all the account users in my workspace. I can click on confirm, right? So now you can see all the account users. So whatever users are attached to this particular account, they will have the manage privilege to Hindi underscore table 1 table. Okay. Now if I want to revoke the access, so what I can do, I can just select what all accesses do I want to revoke, and I can click on revoke. That's it. So now the permission has been revoked, right? So if I can so access management works in this similar way, that if I can provide the access, I can also revoke the access. So Metastore admins owners of an object and users with the managed privilege on an object can grant and revoke access. To learn more how to manage privileges in Unity Catalog, you can visit this particular link. Okay. Then comes the default access to database objects in Unity Catalog. So Unity Catalog operates on the principle of least privilege. Okay. So just keep this particular thing in your mind, right? That Unity Catalog operates on the principle of least privilege. What this particular thing means is that we should only provide the minimum privileges that is required to complete a job. So let's say there is someone who, or let's suppose there is a BI team. Okay, there is a BI team who wants to create a dashboard on my database. Okay, so for creating a dashboard, only read access is more than enough, right? He should not have the manage access or maybe some kind of delete or alter access, right? I will only give the read only access. The BI team will read my data from here and it will create the required dashboard, whatever is required, right? So this is what this least privilege principle says, that where users have the minimum access they need to perform their required task. When a workspace is created, non-admin users have access only to the automatically provisioned workspace catalog, which makes this catalog a convenient place for users to try out the process of creating and accessing database objects in Unity Catalog. Okay, so users should have the minimum access which they need to perform the required task, right? And the non-admin users only have the automatically provisioned workspace catalog access when they are first of all added to any kind of workspace. Okay. Then working with database objects in Unity Catalog. So working with database objects in Unity Catalog is very similar to working with database objects in a registered that are registered in Hive Metastore, which are the with the expectation that Hive Metastore does not include catalog with the in the object namespace. Okay, so working with database objects in the Unity Catalog is very similar to database objects that have is similar to the Hive Metastore. Okay, just only the exception is that Hive Metastore does not include catalog in the object namespace. That's the only exception that Hive Metastore has. You can be familiar with ANSI syntax to create database object, manage permissions, and work with data in Unity Catalog. You can also create database objects, manage database objects, and manage permissions on database object using the Unity Catalog Explorer UI. So using the Unity Catalog Explorer UI, we can perform any of these things. We can create database objects, we can manage the database objects, and we can also manage the permissions on the database objects. If you want to read more about this, you can go on to this particular link, but it's more than enough for right now. Okay. Then managed versus external tables and volumes. So tables and volumes can be managed or can be external. So this thing we have already talked about few minutes ago, right? So now let's understand what exactly managed tables are and what exactly external tables are. Okay. Right. So managed tables are fully managed by Unity Catalog, which means that Unity Catalog manages both the governance and the underlying data files for each managed table. Okay. So Unity Catalog will be responsible to manage even the governance part, means handling the metadata and all those stuffs, as well as also the data files that are present in that particular table. So Unity Catalog will be handling both of them. Managed tables are stored in Unity Catalog managed location in your cloud storage. Okay, so managed tables are stored where? In the Unity Catalog managed location in our cloud storage. Managed tables always use delta lake format, right? You can store managed tables at managed store. You can store managed tables at metastore, catalog, or schema levels. Okay, so we can store the managed tables at any of the hierarchy that we have. Either we can store it at metastore, catalog, or even the schema levels. Then we have external tables. So external tables are tables whose access from Databricks is managed by Unity Catalog, but whose data lifecycle and file layout are managed using our cloud providers and other data platforms. Okay, so only the access will be managed by the Unity Catalog. That basically the ACL, the access control list, will only be managed by Unity Catalog. Rest of the things, that is the lineage, right, data lifecycle, file layout, and all these things will be the responsibility of the cloud provider or any other data platform that we are using to manage that particular table. Okay. Typically, you can use external tables to register large volumes of your existing data in Databricks, or if you also require write access to the data using tools outside Databricks. Okay. External tables are supported in multiple data formats. Once an external table is registered in Unity Catalog Metastore, you can manage and audit Databricks to access it and work with it. Unlike you can with managed tables. Okay. So once the external table has been registered to the Unity Catalog, so we will have to manually register this particular table to the catalog metastore. Then you can manage and audit Databricks access to it. Okay, so unless it has not been registered with the Unity Catalog Metastore, we will not be able to manage and do the audit of that particular table. Okay, then we have managed volumes. So similar to tables, the difference will be same. That managed volumes are fully managed by Unity Catalog, which means that Unity Catalog manages access to the volumes storage location in your cloud provider account. When you create and manage volumes, it is automatically stored in the managed storage location assigned to the containing schema. Cool. So exactly the same thing, just the difference is of the volume. Then external volumes represent existing data in storage locations that are managed outside of Databricks but registered in Unity Catalog to control and audit access within Databricks. When you create an external volume in Databricks, you specify its location, which must be a path that is defined in the Unity Catalog external location. Okay. Now, why do we need two types of volumes or two types of table, that is this managed and external thing? So let's understand this. Okay. So Databricks recommends managed tables and volumes for most of the use cases because they allow you to take full advantage of Unity Catalog governance capabilities and performance optimization. For more information, you can visit this particular link. So Databricks obviously will suggest us to use the managed volumes or the managed tables so that we can take the full advantage of our catalog, of our Unity Catalog governance capabilities, as well as we can also get the advantage of the performance optimizations that we have inside our Databricks environment. Because if we are using our external tables, so even the Unity Catalog governance capabilities has certain limitations on those particular tables. Okay. Now cloud storage and data isolation. So why like here we will be understanding why do we need these managed storage and these external storages. Okay. So firstly, if I talk about the managed storage, so default locations for managed storage and managed volumes, that is unstructured and tabular non-tabular data that you create in Databricks. Okay. These managed locations, storage locations, can be defined at a metastore, catalog, or schema level. Okay. You can create managed storage locations in your cloud provider, but their life cycle is fully managed in Unity Catalog. So storage location, for sure we can provide for these managed storage in the cloud provider, but whole of the life cycle will be managed by the Unity Catalog only. for both of the tables and the volumes, right? These storage, like these managed storage location will define what at the, we can define them at the meta store level, catalog level, or even the schema level. Okay, then comes storage level, where external tables and volumes are stored. These are the tables and volumes whose access from Databricks is managed by Unity Catalog, but whose whose data lifecycle and file layout are managed by the cloud provider and other data platforms. So typically you can use external tables or volumes to register large amount of your existing data in Databricks, or you can only or if you only require write access to the data using tools outside Databricks. Okay, so why we typically use these external tables or volumes is because if we want to, like, let's suppose if we have petabytes of data, right? So we will not be using a table to store, a managed table to store all those petabytes of data if we are not accessing that particular thing on a daily basis. So what we can do is we can use a kind of external storage, right, or an external table where we will be dumping all those data, right, which we are not using on a daily basis, as well as we can all we also create these external tables when we don't have that particular, let's suppose if we want to use some X tool, okay, and this X tool does not have any kind of connector with my Databricks. Okay, so this is my Databricks environment and it does not have any kind of connector. So what we will do is we will create an external table, right, and we will be connecting to this particular X platform. Okay, so here you can see the write access of the data, or if you require write access to the data using tools outside of the Databricks. Okay, so this is what it's saying. So these are the two reasons that we can create some kind of external tables, right? Now governing access to cloud storage or cloud storage using external location. So both managed storage location and storage locations where external tables and volumes are stored use external location secureable objects to manage access from Databricks, right? So we are already aware about this fact that if we are dealing with the external table or external location, we will have some kind of storage credential that will manage access with my Databricks environment. Okay, external location objects reference a cloud storage path and storage credential required to access it. Okay, storage credentials are themselves Unity Catalog secureable objects that register the credentials required to access a particular storage path. Through these securables ensure that access to storage is controlled and tracked by Unity Catalog. Okay, so using these storage credentials, right, Unity Catalog will be able to, okay, using these storage credentials, Unity Catalog will be able to manage that who are who can access that these particular tables, right, or any kind of object, and track if any of the changes is made by anyone, right? And it will also ensure that only the access provided people can access that particular object, right? So here you can see we will have some kind of storage credential. So we have two storage credentials right here. So one storage credential is for my bucket/tables object, and the other storage credential is for my bucket/staging/volume1 object, right? So here we have basically three external locations created. So external location 1. So external location 1 has storage credential 1. So if it has storage credential 1, it will have the access of this particular object, that is bucket/tables. And because we have a star here, so it will have the access to all the tables present inside this tables directory or maybe the tables object, right? If it has other if it can have some data, so it will have the access to data. If there are multiple other tables that are present inside this directory, it will have the access to all the tables. Then we have external location B, because again it has storage credential 1, so it has the access of bucket slash tables slash table 2. Okay, now my access external location C has access of storage credential 2, right? So here you can see that location is now bucket slash staging slash volume 1. Okay, and inside now inside these tables again we can have multiple things. So here you can, if I talk about, so let's say this can be by S3 object or maybe S3 bucket, right? From this root we can have two directories. One directory is tables, so this directory will be accessible to all the external location which has the storage credential as 1, and this staging folder will have can be accessible by all the people who has storage credential 2. Inside this table directory we again have subdirectories, that is table 1 and table 2. So again external location 1 has the access of table 1 and external location B has access of table 2. Staging has only one volume that has been that is inside it, so external location C has access to this particular volume 1. Okay, so based on this storage credential, the access was provided to the given external location. So here you can see in this diagram, each external location refers to a storage credential and cloud storage location. Okay, so external location, it refers to a storage credential and to a cloud location. So this is the cloud storage location. Multiple external locations can refer to same storage credential. Here you can see that multiple external locations are referring to the same storage credential, right? Storage credential 1 grants access to everything under the path bucket slash tables. So both external location A and B reference to it. Okay, again you can see external storage credentials are one storage credentials are having multiple external locations attached to it. Okay, then managed storage location hierarchy. So what is the hierarchy of the managed storage location R? So the level at which you define managed storage location in Unity catalog depends on your preferred data isolation model. Okay, so how much isolated do we want to keep our data? In that particular case, we can define our Unity. Sorry, we can define our data isolation model. Your organization may require that certain types of data can be stored within specific accounts or objects in the cloud tenant, right? Unity catalog gives you the ability to configure, manage and manage stored locations at metadata store, catalog or schema level to satisfy such requirements. So Unity catalog gives us the freedom that we can configure these managed store at the meta store level, at catalog level or at schema level, whichever suits our requirement. For example, your organization says that your organization has a company compliance policy that requires production data related to human resources to reside in bucket S3 / my company HR prod. Okay, so this is the bucket that we have, right? And all the HR related data that is there in the production should be there inside this particular bucket only. Okay, now in Unity catalog you can achieve this requirement by setting a location in the catalog level. So this can be achieved by setting this particular requirement. We will be passing on this particular bucket path to the catalog level. So what we will create is creating a catalog called, for example, HR prod. Okay, so we will create a catalog named as HR prod and we will assign the location of this particular bucket, right, to this particular catalog, right? What we will do is we will create an HR_prod catalog. right? And this HR underscore prod catalog will point to this particular path, S3 slash my company underscore HR, hyphen HR hyphen prod. Okay, this particular path you can see right here. Cool. So this means that manage tables or volumes created in the HR prod catalog, for example, using create table HR prod dot default dot table, stores their data in S3 my company HR prod dot unity catalog. Okay. So if any kind of changes will be made to this particular catalog, let's say if we are creating a table inside it, so it will store all the metadata of the table in this particular location, that is S3 my company HR prod slash unity catalog. Okay. Optionally, you can choose to provide schema level location to organize data within the HR prod catalog at a more granular level. So if I want, I can also create a catalog on a more granular level. I can even create the catalog on the schema level also, but generally it's not that much required, right? Even creating the catalog on the, like creating the unity catalog on the catalog level will be sufficient enough to store all the metadata. Now if storage isolation is not required for some catalog, you can optionally set a storage location on the metastore level also. Okay, so if that much storage isolation is not required, we can also set the storage location to metastore location, but it is generally recommended that we create a catalog for, like we create a managed storage location for all the catalogs that we are having, right? This location serves as a default location for the managed tables and volumes in catalogs and schemas that don't have assigned storage. Typically, however, Databricks recommends that you assign uh, separate managed storage location to each catalog. Cool. That's exactly what I said right now. Then system evaluate the hierarchy of system location for hierarchy of storage location from schema to catalog to metastore. Okay. For example, if a table my catalog dot my schema dot table is created in my region underscore metastore, the table storage location is determined according to the following rule. Okay, so if a location has been provided to my schema, it will store there. Okay, so if the storage location for schema is provided, so the metastore will be, or the metadata will be stored there. If it is not provided for my schema, it will search for the location for my catalog. If it is provided, it will store there. And even if it is not provided for the catalog thing, then it will store inside this my region underscore metastore. It means on the topmost hierarchy of the unity catalog. Okay, so there are these are the type of you can see that if there is a managed storage location provided not provided for schema 1 and for catalog 1, it will store in metastore. If it is provided for catalog 2, the managed storage location for if it is provided for catalog, it will store in catalog 2. And if it is provided like in the schema level storage, so if it is provided for schema 3, it will store in the schema 3 only, like schema level storage. Now if I talk about the environment isolation using workspace catalog and binding. Okay, so by default, catalog owners, that is, and metadata admins, if they are defined for the account, can make a catalog accessible to the users in multiple workspaces attached to the same catalog metastore, right? Organizational and compliance requirements often specify that you keep certain data like personal data accessible only in certain environments. Okay, so let's suppose if we are working on a project where we have a very sensitive data, let's suppose we are working on some kind of finance project where we have the credit card informations of our customers, right? So in that particular case, we will not make it accessible to all the environments. We only want that particular information is only accessible to a certain environment where it is required. So that thing can also be done. Okay. You may also want to keep production data isolated from development environments to ensure that certain data sets and domains are never joined together. Okay. So you can also we can also keep certain environments. So let's suppose here if you see, right, so we can keep the development and staging environment always separated from the production environment, and this is what exactly we do, right? We always, so if I talk about the SDLC, right, that is software development lifecycle, right, we usually have multiple environments, like we have dev environment, right, then we have our testing environment, then we have maybe our UAT slash staging environment, right, and then we have our prod environment, right? So we will always want that my prod environment is always separated from these environments. Why? Because this is the point, or this is the environment where my code is running, right? My business depends on this particular environment, right? And whatever things are newly being developed, each and everything will be present in this particular environment. So I will keep prod environment separated from my dev, test, or UAT and staging environments, right? So this can also be done. So you can see right here that there are separate catalogs for separate environments. So dev environment and staging, sorry, dev catalog and staging catalog, it has the access. So staging has access to both dev and the staging. Dev has only access to the dev workspace, right? And here you can add groups to those particular workspaces, right? So developers has only access to the dev workspace, whereas the testers has the access of for staging, both developers and testers has the access to them. Okay. Similarly, if I talk about my production environment, so production environment first of all is isolated, right? It's isolated, and only testers and analysts are having the access to this production workspace. Similarly, we have something as bu1 underscore dev, right? So we have created the dev and the staging environment in a same workspace, right? So here bu developers and bu testers has the access of this particular workspace, right? And the production is separated from the staging and development. So the bu users are having the access of the prod workspace. Okay. So this is how we can isolate our workspace and environments also, and depending on the user, right? Because we already know that in Databricks we have the least access policy, right? That least access should be given to the users, right? So based on the requirement, the users will be attached to the required workspaces. Cool. Now let's understand how can I set up a Unity catalog in my organization. Okay. So to use Unity catalog in the Databricks workspace, it must be enabled for Unity catalog, which means that the workspace is attached to Unity catalog metastore. Okay. So the very first condition for creating or for accessing the Unity catalog is that it should be accessible, or it should be attached to my catalog metastore. Okay. Then how does the workspace get attached to metastore? Typically, when you create a Databricks workspace, in a region for the first time, the metastore is created automatically and attached to the workspace. Okay. So this is when we create a new Databricks workspace. So for some older accounts, an account admin must create a metastore and assign the workspace in that particular region to the metastore. Okay. So if the account is old, or if it has been created earlier, right? So in that particular case, the account admin, right? You can see right here that the account admin will have to create a meta store, and it will have to assign that particular workspace to that particular meta store. Okay. If you have already, if an account has a meta store assigned to a region, an account admin can decide whether to attach the meta store automatically for all new workspaces in that region. Okay. So this is the thing. Then whether or not your workspace is enabled for Unity Catalog automatically, so the following steps are required to get started with the Unity Catalog. So first of all, create catalog and schemas to contain databases, objects like tables and volumes, right? Then you have to create managed storage locations to store the managed tables and volumes in these catalogs and schema, and then grant user access to catalogs, schemas, and database objects. Okay. Then we have certain kind of requirements and restrictions for the Unity catalog part. Okay. So first of all, okay. Okay. So there are certain requirements and restrictions for the Unity catalog. So Unity catalog requires specific types of compute and file formats as described below. Okay. So region support, if I talk about, so all the regions support Unity catalog. Compute requirement. So Unity catalog is supported on clusters that run on Databricks runtime 11.3 LTS and above, right? So currently there is the runtime is something as 17 point something for the Databricks that we usually use, right? So if we are having 13.11.3 or above runtime, we will be able to use the Unity catalog. Cluster running on earlier version of Databricks will not provide a full support of Unity Catalog. Okay, it will have some kind of restricted support of Unity Catalog. Talking about the file format support, so we can have, if we are working on a managed table, so we can have the support of delta table format, right? And if we are working with external tables, so the files that are supported are delta table, CSV, JSON, Avro, Parquet, ORC, and text. Then securable object naming requirements. The following limitations apply for all object names in Unity Catalog. So object names must not exceed 225 characters, right? The following special characters are not allowed. So we cannot use dot, right? We cannot use space, we cannot use forward slash, we cannot use the ASCII control characters, that is from 0 to 1F in the hexacode, and we cannot use the delete character, that is 7F of hex. Then Unity Catalog stores all object names in lowercase, and when referencing Unity Catalog names in SQL, you must use backticks to escape the names that contain special characters such as hyphens. Okay, so if the catalog name is having hyphens, in that particular case, if you are using the Unity Catalog names in SQL, you can use the backtick, that is below the button below your escape button in your keyboard. Okay, so that is what the backtick is. Then we have certain limitations in Unity Catalog. Okay, so so these Unity Catalog, like these limitations are mostly for the older runtime versions of the Databricks. Okay, so we will go through quickly because we are already aware about the fact that we are using, if I come here, right, and if I go to my workspace and if I open my notebook, right, so in the delta table history video, right, that we have done, we were having the information about my runtime. So if I scroll down, so this is where we have used the JSON. Most of the things we have covered, right? I guess there is nothing left to be covered now in Spark. Okay, we are going upwards, down. Scroll down, why it's not scrolling down? Data validation. Okay, and below this, right, so here we have the delta history thing. So it should load the data in a while. Right, so here in the dot history one, if you will scroll at the last, so you will see we are using 17.3.x version right now. The Databricks runtime is 17.3.x. Okay, so mostly these versions, like these limitations are based on some kind of versions. So groups that were created previous in the workspace cannot be used in Unity Catalog for the grant statement, right? So there is no such limitation for 17 or so. So what I would suggest is you guys can go through this particular limitations, right? If you have any kind of issue, obviously you will not face any of the issues because we are using 17 version right now, and these versions are of previous thing. And I don't think that you will be creating your own runtime of the previous version and then you will be facing these issues and you will be using these particular commands, right? So you can just go through these limitations, even if even it is not very useful if I talk about for the interview point of view. So this is not that much useful. So either you can skip it or you can go through it by yourself. If you face any kind of issue, for sure you can ping me down in the comments. I will be happy to reply to it. Cool. So this is pretty much it for this particular video. I hope you learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye.